Hi, and welcome back to Ruwane's Chemistry B. We're talking about gas laws here. Here is the cheat sheet I had you guys print out or make if you didn't have a printer. And remember, we had all these laws to use, but they're all combined in this one gas law. And we are going to use this to determine how to set up this formula. Okay, this will be Monday. Tuesday, we're going to use this formula, or not Tuesday, Wednesday. Friday, we're going to put them intermixed so you guys can determine which one to do. The following Monday, we will learn about atmospheric pressure barometers and do our review, and next Wednesday will be your test on gas laws. So make sure you understand what's going on. Today you're going to do this video. I'm going to do number 1 and 2 with you. Excuse me, they're not 1 and 2, they're example 1 and 2 with you. If you want my help, you will have to have 1 and 2 done on your worksheet, so I know that you saw this video. Okay, so let's get to it. Here is your worksheet, and when they do these problems, a lot of times they say it's at standard temperature and pressure, and they don't say standard in temperature and pressure, they say STP, okay? So they usually just write STP right here. And then people don't know what to do. So let's make sure we do. Standard pressure is, it could be 1 atmosphere, which is the same as 760 millimeters of mercury, which is the same as 101.3 kilopascals. So depending on what unit your pressure is going to be, and if they say standard pressure for a condition, an initial or final condition, you're going to put in one of these numbers. If it says standard temperature, you are going to put in 273 K. Why? Because when we do these problems, they always have to be in Kelvin, okay? So make sure you have that typed in on your worksheet if you need my help. So let's do our first 2 examples. A syringe starts with a pressure of 12 atmospheres and a volume of 3.2 liters. These guys are a pair. When it is 12 atmospheres, our volume is 3.2 liters. So this is our pressure 1 and our volume 1. You could label it pressure 2 and volume 2. It won't make a difference as long as your pairs are together, okay? Now we have a new pressure, that's pressure 2. And what is the new volume? Our volume 2 is our question mark, and they don't give us any information. So on your worksheet, I want you to put in your initial, right here, pressure 1, with the units. The units are very important, and you will need your units to get full credit on your worksheet. Our volume is 3.2 liters. Now the new pressure is 3200 kilopascals, and they want to know what our volume 2 is. Okay, so this chart tells me I do not need moles, they didn't give it to me, and I do not need temperature. Basically, if the temperature is the same, let's say it's 100 K and 100 K, I just made that number up. If it's the same, you can cross it out too. If the temperature is constant, you're just going to cross it out. Okay? So, how do I know which formula to use? Well, we have our combined P1 and V1 equal divided by temperature 1, and you could have moles 1 under there too. That's not in here, but that is the full combined, and that equals P2 V2 over T2 N2. Now, do we need N? No, cross it out. Do we need temperature? No, cross it out. So our formula is P1 V1 equals P2 V2. Okay, and that you are going to have to put in your worksheet. So on my problems here, let's see, electrochemistry. On my problems here, you need to actually show me the formula after it's rearranged. So what are we solving for here? We're solving for volume 2. I need to get that guy alone. So I am going to divide by pressure to get rid of pressure, but whatever I do on one side, I have to do on the other. Okay? So now what you have to do is show me your rearranged formula. So my rearranged formula is P1 V1 divided by P2. So that's what you'll have to put in your worksheet. And now what you're going to do is you're going to plug in your numbers. But before you do that, you need to make sure your units match. That's one of the beauties of these charts. This is in atmospheres and this is in kilopascals. My units do not match. That means I have to change one of these to match the other guy. If my units don't match, the number will come out wrong. Also, since this is in liters, what I'm solving for will be in liters. The units have to match. The other question you ask yourself is temperature in K. Well, we don't care about temperature in this problem, but if it wasn't in K, we'd have to convert. So I am going to change my kilopascals to atmospheres. You could change your atmospheres to kilopascals. It doesn't matter as long as the units match. Okay? So I have 3,200 kilopascals. I don't want kilopascals anymore, so I put it on the bottom. And I want atmospheres. Now, what is true? For every 1 atmosphere, and just in case you forget, I have them up here. For every 1 atmosphere, that does equal 101.3 kilopascals. Multiply by the top, divide by the bottom. So when I plug it into my calculator, I get 31.59 ATM. So I don't want that anymore. I have 31.59 ATM. Do you have to show me your work on that? No. Would you like to write on a piece of paper and put number 1 and show me your work? So if you have problems, I can check it. Sure, you can take a picture and turn in this work. But if you don't want to, you have to fill in the chart. You have to show me your formula rearranged, and then you have to give me your answer with units. So now I get to plug everything in. My pressure 1 is 12 atmospheres. So 12 atmospheres. Make sure you have your units so you can see what cancels out. Okay, my volume is 3.2 liters. Pressure times volume. Pressure times volume. Some people like their times there. Okay. On the bottom, I have pressure 2, which has to be in atmospheres because I did atmospheres. Again, if they're both kilopascals and they cross out, that's fine too. 31.59 atmospheres. And this is going to give me my volume 2. Notice my atmospheres cross out. I'm left with liters, so my volume 2 is going to be in liters. Now, how do I want you to do this? Multiply everything by the top. Okay, 12 times 3.2 equals divided by 31.59. Okay? Okay, so I get 1.2155 on my calculator. Hopefully I did that correct. Sometimes I make a mistake. I'll double check that in a sec. And I have 2 sig figs, 2 sig figs, 4 sig figs. I underline the 2, that's the least number. Does my 1 round it? It does not. I have 1.2, and that would be liters. Okay, so that's my new volume, and then your answer with units will go there. I want to show you one thing, one calculator mistake I see a lot. Let's say I have 2 times 3 divided by 4 times 4, okay? Some people do this, and this is wrong. 2 times 3 equals divided by 4 equals times 4 equals. That is wrong. You divide by everything on the bottom. So that would be 2 times 3 equals divided by 4 equals, and since this is on the bottom, we divide again by 4, okay? So make sure that you know how to do that. I'll put the answer there. Okay, so you would get 0.375. So make sure you know how to do that when you have two numbers on the bottom. Also, I did double check this number, so we're good there. Okay, now my second example, we use STP. So I have 700 milliliters of gas at standard temperature and pressure. Okay, this is my initial or my final, doesn't matter, spelled that wrong. See, don't you miss my misspellings? I know you guys do. Okay, and we have the new volume is 2 liters. What is my new temperature? So this is my volume 2, and this is my temperature 2, and that is my question mark. So let's start out. We have 750 milliliters. Or no, we don't. We just have 700.00 milliliters at STP. Well, here I have volume and temperature. So my standard temperature is, this would be 1 atm, okay? But we don't care because we're not using pressure. And my temperature would be 273 K. Okay, my new volume is 0.200 liters. What is my new temperature? So, do your units match? This is in liters, this is in milliliters, okay? So, they don't match. We usually keep things in liters, so I'll keep it in liters. We have 700.00 milliliters, and I don't want milliliters, I want liters. There's 1,000 milliliters in 1 liter, which is going to give me 0.70000. It's milliliters, okay? 1, 2, 3, 4, 5 significant digits, so I should have 1, 2, 3, 4, 5 significant digits. So we change this, and again, you could change this to milliliters. They're going to cross out as long as they're the same. So 0.7, 1, 2, 3, 4 milliliters. Okay, so now my units and temperature match. So let's put down our formula, which is P1 V1 T1 N1 equals P2 V2 T2 N2. And let's cross out what we don't need. They didn't talk about pressure at all in here. We do know standard pressure is 1 atmosphere, but they didn't give us the other one, so we assume it's constant. So our pressures are gone. Okay? Our moles, didn't talk about that. So our moles are gone. So what's left? V1 T1 equals V2 T2, and what you need to show me is it rearranged. Okay, so I am solving for temperature 2. That is on the bottom. Okay, now here's the trick. If I solve for T2 on the bottom, I would be solving for 1 over T2. We can't have that. We need to move T2 on top. I can multiply by T2, both sides, and it'll cross out. Let me show you what just happened. And this goes away, and it gets moved over and up. So it gets moved diagonal. You can always move, when we set up ratios like this, you can always move it diagonal across. That's what the math does. So now our T2 is up here, V1 T1 equals V2, right? But this is the guy I have to get alone. So I move this kitty corner, and if you multiply by T1 on both sides, you'll see my T1 moves up there, and that goes away. And then my V1's here, my V1 has to go down here. Okay? Why? Because I would divide by V1 to get rid of that, which means I'd do it the same on the other side. So my formula rearranged is T2 equals V2 T1 over V1. Okay? So now if I plug in my thing, that's my T2 that I'm solving for. My volume 2 is 0.200 liters times my temperature, 273 K, divided by my volume 1, which is 0.70000 liters. I put milliliters there. Sorry guys, that's liters. Okay. Okay, that's what that's going to equal. So let's put that in our calculator. 0.200 times 273 equals divided by 0.7. Let's see what we get. Okay, so I got 78K. Notice my liters crossed out and I was left with Kelvin. So 78 Kelvin. Why did I put that 0 at the end of 78? Because I had 1, 2, 3 sig figs, 1, 2, 3 sig figs, and 5 sig figs. 1, 2, 3 was my lowest. How do I keep it 78 and add a sig fig? I pop a 0 at the end. Okay? So now you have problems to do on your own. You need to plug in your initial and final there. You need to show me your rearranged formula, okay, and answer with units. You got to put there. And that's what I need to see on this worksheet, or you can show me a picture of your work done. Now, I am going to redo some of that math rearrangement that I just showed you guys for those who have problems with algebra. Feel free to end this and work on your worksheet if you're good with your math. Remember, you must have your first 2 examples done if you want my help, and you have to show that to me on your worksheet. Okay, so let's say that we have our P1 T1 equals P2 T2, and we want to solve for T2 down here. Now, a lot of people just rearrange everything, but your T2 is still on the bottom. So if I've got rid of my P2 and put it over here, you would be solving for 1 over T2. T2, whatever you're solving for, has to be on top. Okay, so let's go through that slowly algebraically. I need to get T2 on top, so I'm going to multiply both sides by T2. Okay, so my T2 is gone, and I have T2 times P1 divided by T1 equals P2. Okay, that's what I have. But I am solving for T2. This is what I have to get alone. So I have to multiply, I have to get rid of T1, so I'm going to multiply this side by T1, and I'm going to multiply this side by T1, and this cancels, and I have T2 P1 equals P2 T1. Okay, but remember, we're solving for T2. This is still not alone, so I'm going to divide by P1 and divide by P1. This goes away, and I now have T2 equals P2 T1 P1. Okay, that's step by step. Seems like a lot. Let me show you the very quick way of figuring this out without making math errors. Now you notice my T2 is here, and I moved it kitty corner or diagonal up to the top. That's what this math did. It just moved it over to the other side on the flip side of it. Okay, so let's look at this in another way. I have P1 T1 equals P2 T2. Now notice there's no addition here. There's not. It's only if you're multiplying or dividing on both sides can you do this. As soon as you put an addition sign in there, sometimes it works, but I'm not going to get into all that right now. Okay, so if I want my T2 on top, I can move it diagonal right there. So now I have P1 T2 equals T1 equals P2. There we go. I just moved it diagonal. That's what your math did, okay? But remember, we want this T2 alone. That means I can move this diagonal there, and I can move that diagonal there, and I will have T2 equals P2, here's my diagonal T1, and here's my diagonal down there, P1. Okay, so now we ended up with the same thing, but instead of doing all the math, multiplying on both sides, I just crisscrossed it. Why does that work? Well, let's just see right here. In order to get rid of it, I put it there, and then I multiplied on top here. All I did was get rid of it here, and I moved it across and up. I moved it crisscross. Okay, so that's the quick and easy way to do the algebra with these gas laws. Okay? Text me if you have any questions, email me. Private comments seem to work faster than my email. So if you put a private comment on the Google Classroom, it'll work faster.